Hello, Algebra 2 students for semester 2. This is Mr. Bear, and you can actually see me because I'm on Zoom right now too. But anyway, I am making the video for Skill 12, which is about rational exponents. And so what we're going to do is we are going to talk about what these mean and how we translate between the rational version and the radical version. So you may remember the last lesson, Skill 11, was about simplifying radicals. So we're going to connect the idea of rational exponents to radicals. So our essential question today is why structure the expressions in different ways? You will be able to simplify numbers raised to rational exponents by converting them to radical form and extend the properties of exponents to rational exponents. Okay, so let's start with the definition. So if I have x to the power of m divided by n, we are going to say that we can either write this as the nth root of x to the m or the nth root of x raised to the m power. Okay, and we'll talk about why those things can happen and which form would be more advantageous within a problem. So let's start with some vocab. So index, that is just going to be the number in the radical. Okay, sometimes I call it the root. Okay. Radical form is when you write things with the radical symbol. Okay, so you're going to have that little radical symbol. I don't want to just say the square root symbol because not all radicals are square roots, but it must, so you know something's in radical form if it has this little square root looking symbol, except it's not really a square root, it's just generally called a radical. Rational form means it has a fraction exponent. Okay. And you may be wondering, why is there a random picture of a flower in these notes? I'll explain that in just a moment. Actually, I'll explain it right now. So a way to help students remember how to write the rational exponent, I use the analogy of flower power. So the fractional exponent has a numerator and a denominator. Okay, and so think of it like the flower. The numerator is where the power is going to be held in our fraction, and we have flowers that grow up out of the ground. So think of the flowers above the ground, and it has the power. Okay, the ground is going to act like the fraction bar, and what holds the flower into the ground are the roots. Okay, and the roots is going to tell you the index of the radical that we're working with. Okay, so if I wanted to write the cube root of x to the 6th in rational form, what I would do is I'd start with my variable x, and I'm going to make a fractional exponent. My root, remember the root is the denominator, and that's going to be your index. So in this case, that would be the 3. That's really tiny to see. Let me see if I can make this bigger. The numerator has the power, and so it's going to be 6. And if we simplified that, we would get x squared. Okay? But the point of this right now is just to show how to write it in rational form, rather. And if I have w to the 2/3, if I write that in radical form, I need a radical symbol. W goes under the radical. I have a 2 as my power, so the 2 can go with the w. 3 is the denominator, and remember the denominator has the roots, so I'd put the 3 in the index spot. Now I could have also written this as the cube root of w, and then I could have squared the whole thing. Okay, and we'll talk about which form is going to be more advantageous as we look at different examples. Okay, so now let's talk about evaluating some of these. So we're going to practice just being able to actually apply this idea to these problems. So 8 to the 2/3, that's the same as saying the cube root, so the root is 3, So cube root of 8, and then the power is the 2. So I can either think of this as the cube root of 8 squared, or I could think of it as the cube root of 8 squared. If I do cube root of 8, I know that's 2 because 2 times 2 times 2 makes 8. And when I square that, I get 4. If I do the cube root of 8 squared, that's the same as saying cube root of 64. Well, 64 can be multiplied as 4 times 4 times 4, so you'd still get 4 as your answer. So whichever way is easier for you to think of. This one wasn't too bad because both ways weren't too bad, but some of you may know the cube root of 8 better than the cube root of 64. Next one, we have 4 to the 1/2, so it's a square root of 4 to the power of 1. Usually we don't have a 2 in that index when we're dealing with square roots, so really this is just square root of 4, which will be 2. Next one, 27 to the 2/3. I have a root of 3, so it's a cube root. And we have 27 squared. I think the cube root of 27 is a little bit easier for people to do because we know that 27 is just 3 times 3 times 3, so the cube root is 3. And then we have to square that value because we had the power of 2. So the answer would be 9. And then 9 to the 3/2, well, it's another square root because my root is 2. So square root of 9 and then cubed. Well, you probably know the square root of 9 is 3, so we do 3 cubed, which is 27. Okay. Now there is another way to think about these. These fractional exponents actually do mean something, and some people might want to see this. If I take the 8 and I do the prime factorization, I end up getting 2 times 2 times 2. Okay, now when I'm looking at this, remember the original problem that we had was what is 8 to the 2/3? So here's 1/3, 2/3. 2/3 of my total prime factors make the value 4. Okay. If I look at that idea with the next example, so 4 to the 1/2, if I take that 4, I can break that down into 2 times 2. And then because we want the 1/2 power, half of my total factors is the 2. So that's another way to think of it. For the next one, when I think of 27, I can break that down into 3 times 9 and then 3 times 3. So we have 3 times 3 times 3 is the prime factorization. And we were asked to determine, well, what is 2/3 of that? So 1/3, 2/3, that gives me 9. Okay? And then the final one here. So I have 9, which I can break down into 3 times 3. Now, this asks for 9 to the 3/2. So you might be thinking, well, Mr. Bear, your logic is wrong here because these two 3's together make one whole. Well, remember, 3/2 is the same as 1 1/2. So here's my one whole set. Here's another whole set. Well, I need half of that. So 3 times 3 times 3, 27. Okay, so it still works out. But am I going to make you think of it like this? No. If you can do it like we did the top row, that's what you really need to know how to do. Okay? All right, so now what we're going to do is we're just going to do a little bit more practice here. But this time we're going to simplify. Let's see. So if I look at this one, 8 to the 4/3. Well, this is the same as saying cube root of 8 to the power of 4. Cube root of 8 is 2, so we do 2 to the 4th, which is 16. Next one, 4 to the 3/2. My root is 2, so I have a square root of 4 to the third power. Square root of 4 is 2, so we have 2 to the third, which is 8. Okay. Then we have 9 to the negative 1/2. This one, be careful. So this is the same as 1 over 9 to the 1/2, because remember, negative exponents, we rewrite to the denominator. And then I can rewrite the 9 to the 1/2 as the square root of 9. So my final answer for this is just 1/3. 25 to the negative 3/2, well, that's the same as 1 over 25 to the 3/2. So root is 2, so it's a square root of 25 to the third. Square root of 25 is 5, and then 5 to the third is 125. Okay. Now the next one, this is negative 8 to the power 4/3. Okay, so on this one, the negative is not a part of the exponent, so I leave the negative there. And then I have 8 to the 4/3, so it's cube root of 8, and then to the 4th power. Cube root of 8 is 2. 2 to the 4th is 16, but we have that negative, so the answer to this one is negative 16. Sorry, I'm going to kind of separate some stuff here. The next one, however, we actually are taking that negative 8 and we're doing the cube root. Cube root of negative 8 is negative 2. But now I'm taking that negative 2 and raising it to the 4th power, so that makes positive 16. Okay. All right, and then the last one in this section, we have negative 27 to the 4/3, so that negative is not with the parentheses. 27 to the 4/3, we have a root of 3, so the cube root of 27 to the 4th. Cube root of 27 is 3. 3 to the 4th is 81, but we have that negative in the front, so negative 81. All right, so that is how we're going to evaluate these. Now, the last piece that we're going to look at is how to use our power to a power and simplify. So this is why we are going to remember that. When you have a power raised to a power, remember you just multiply your powers, and in this case we'll be multiplying fractions. So I have x to the 2/3 times negative 6 over 1, which gives me negative 12/3, which is negative 4. So we end up getting x to the negative 4, which we know we have to write as 1 over x to the 4th. Okay. The next one, we have 1/5 times 10 over 1, which is 10 over 5, or 2. So this ends up being x squared. Next one, we have 1/2 times 6 to the 1, which gives me 6 over 2, which is 3. So I get 3 to the 3rd. Remember, our base was 3. So my answer to this one is just 27. Then the next one we have, let's take our 2/3 times our 9 over 1. We get 18/3, or 6. So this becomes negative 4 to the 6th power. And I'm just going to use a calculator for this. So negative 4 to the power of 6 gives me 4,096. Okay, and that is how we're going to work with rational exponents.